Here we have a SAT math problem. Okay, let's go to the question. In the figure above, a rectangle is inscribed in a part of a circle. If the length of AD is 4 and the length of DC is 3, what is the area of the shaded region? Okay, here when you look at the given figure carefully, the given part of the circle is 1/4 of the circle. Okay, now to get the area of this shaded region, what I have to do is first I have to find the area of the given part of the circle, that is 1/4 of the circle. Once I get the area of the 1/4 of the circle, from that area I can subtract the area of this rectangle ABCD. So the remaining area represents the area of this shaded region. Okay, here we can get the area of this rectangle easily because we have the dimensions 3 and 4. That is, length is 3, then width is 4. When we multiply 3 and 4, 12. 12 is the area of this rectangle. How do you have to get the area of this 1/4 of the circle? So if I want to get the area of this 1/4 of the circle, I must need the radius of the circle. Okay, here since this ABCD is a rectangle, at each vertex will have a right angle. So here we'll have a right angle and also here we'll have a right angle. Since it's a rectangle, opposite sides are parallel and equal in length. So that is whatever length we have for this side AD, the same length we'll have for this BC as well. So that is 4. So the length of this BC is 4. Okay, now let me draw a diagonal of this rectangle, that is DB. Actually, the diagonal of the rectangle connects the center of the circle D and a point B on the circle. So this DB represents the radius of the circle. Okay, and also let's consider this right triangle BCD over here. It's a 3, 4, 5 right triangle. That is, in this right triangle, this BD represents the hypotenuse because it is opposite to the right angle. And the lengths of the remaining two legs are 3 and 4. In a right triangle, apart from the hypotenuse, if the lengths of the two legs are 3 and 4, then the length of the hypotenuse must be 5. So that's why it's called 3, 4, 5 right triangle. Otherwise, we can use Pythagorean theorem to get the length of the hypotenuse. Anyways, I got the radius of the circle BD, that is 5 units. Now I can get the area of this 1/4 of the circle. Okay, anyways, let me write the stuff over here. Area of the shaded region. Let me write it. Area of the shaded region is equal to, so 1/4 of the area of the circle. We know that the formula to get area of the circle is pi r square. And from this 1/4 of the area of the circle, we have to subtract the area of this rectangle. That is, area of the rectangle is given by length times width. Okay, 1/4 times pi times. So what is the radius of the circle? Just now we got the radius of the circle. That is dB. This is the diagonal of the rectangle. That is 5. So we can plug in 5 for this r. Then we get 5 square negative. This represents the area of the rectangle. L is the length. That is 3. And W is the width. That is 4. It is 3 times 4. Okay, here the value of 5 square is 25. When I multiply this 1 pi and 25, I am getting 25 pi over 4 negative. 3 times 4 is 12. Okay, here we have a fraction and we have an integer. We do subtraction between a fraction and an integer. Whenever I want to do addition or subtraction between a fraction and an integer, I have to multiply the integer by the denominator of the fraction. Once I'm done with this multiplication, I can take this 4 as a common denominator. Okay, let me do it. 25 pi. Now I have to multiply this integer 12 by this 4. 12 times 4 is 48. Since I have multiplied this one and this one, now we can take this 4 as a common denominator. Okay, here I got the area of the shaded region, that is 25 pi negative 48 over 4. I find this stuff exactly in answer choice D. The correct answer choice for this question is D.